we've seen what happens with the property of addition. Now what we want to look at is what happens when you have subtraction taking place. And in this case, the example I'm choosing is to take the rectangular piece of paper and trimming off enough so that it becomes a square. And so we can again look at our situation in terms of we want to find out what the biggest trim value we could ever get. And we have to look at the numbers just a little bit carefully, because now if this is really big and this is really big, I get a margin. If I make this really big and this really small, then I get a bigger margin. So instead of taking high and high, I'm going to take high and low, because then that should give me the biggest margin possible for this trimmed piece of paper and when I'm looking at the values. And so substituting in the ranges that I had posted earlier, the highest value that the trim piece could be would be 6.37 centimeters. Likewise, if I'm looking at the lowest or the smallest trim piece, then I would want to take the smallest length that I could possibly measure and combine it with the highest width. And that should give me the smallest margin possible, which would give me the smallest value for my trim piece. And so in doing that, it's 6.29 centimeters. But when I'm doing the actual calculation for the trim, I would take my values of that I had measured earlier to get 6.33 centimeters. And now I can compare with the values that I could possibly get, and I can see that my range goes up by 0.04 centimeters or down by 0.04 centimeters. And so a good range to pick to take that into account would be plus or minus 0.04 centimeters. So the tricky part is just to make sure that you have a combination that can cover the range of values that you could get by putting in a high value or a low value for the length, a high value or a low value for the width. Not only can we do simple math like addition and subtraction, but we can also do more complicated math, multiplication and division and more. So we're going to look at, first of all, just simple multiplication, in this case looking at the area for our 8.5 by 11 piece of paper. So multiplying by the length and the width, and in this case, I'm going to start off by actually calculating the value that I would get just by using the measured values, and the area would be 606.2634 centimeters squared. Then I can look at the values that I would get if I multiplied out the biggest value for the length and the biggest value for the width. So if these two are big, then my area should be the biggest value. And so I'm going to call that area high. And so multiplying out my largest value that I had for my length, my largest value for the width, I ended up with 607.2568 centimeters squared. And I'm writing all the decimal places my calculator spit out, because I don't know how much this is going to deviate from this one. In fact, in looking at the deviation, I could see that I'm going to call this delta A high, and it deviated by an amount 0.9934 centimeters squared. Similarly, I can look at the deviation for the low end of things. So finding out the lowest value for the area would be using the lowest value for the length, lowest value for the width, and coming out with a value of 605.2708 centimeters squared, or I have a difference between this and my measured value as the lowest end would be minus 0.9926 centimeters squared. And notice that the two ranges aren't identical. There's a slight variation because